We'll have LinkedIn Live on another channel here. What is up, everybody?
How's it going, Joe?
Good. Hey. What's up, Ben? What's up, Matt? Cool. Yeah. Good Friday. So, I just think we're gonna be chatting data engineering today, doing a live Q&A. We did this a couple weeks ago on LinkedIn Live and YouTube. So, anyway, I guess let's talk data engineering.
So, let's do it.
Yeah. So you had an interesting article, Ben, or a video that came out a bit ago. You want to talk about that?
Which one are you referring to? The software engineering versus data engineering?
Yeah.
So I think our chat kind of brought that up, like the whole concept of like someone asked, what's the difference between a software engineer and a data engineer? And I always notice that there's a lot of articles where it's like data scientist versus data analyst, data scientist versus data engineer. And depending on the company you work at, those articles make a lot of sense. But I've started to see a lot of companies sometimes depend on data engineers almost in a somewhat software engineering capacity, depending again on the role and the company and like the size of the company, where they're having to do a lot of like DevOps work just to like manage everything, set up their own cloud, do a lot of like their own infrastructure development and monitoring kind of development. And so sometimes it can feel, I feel like, a little bit of a software engineering role. And also sometimes people interview like it is that way as well. Like they'll ask you a lot of data structured algorithm questions. And so I just kind of wanted to discuss that and talk about how the fact that sometimes it feels like a spectrum, where it's like sometimes a data engineer is more closely related to the analytics team. And sometimes they can almost feel like they're leaning more towards the software engineering team. And so it's interesting because I feel like I got an interesting mix of responses where some people were like, I've never seen a data engineer be in a software engineering light, and some people felt like it was closer. But I thought it was like an interesting way of looking at it, just because again, I see a lot of articles the other way where it's like data scientist versus data engineer, but I'm like, I don't see too many software engineers versus data engineer articles out there.
That's interesting. Yeah, what are your thoughts on that, Matt?
Yep.
So you're muted.
Yeah. Sorry about that. It's interesting because I found that software engineers can make very good data engineers. I think the skills you develop as a software developer for debugging and logical thinking, and especially if you're a software engineer who works at the systems level and so has to think about things at scale and lots of communication between different systems and APIs, then that's a very good preparation for data engineering. Obviously, there are many different subdomains in data engineering, but especially if you're going to be working on things like orchestration, or like you were talking about, Ben, the sort of DevOps side of things, monitoring systems, alerting, getting into custom API connectors to move data around. It's just all very software engineering heavy. So what are your thoughts on this, Joe?
Yeah, I tend to agree. I think it's software engineering provides, I think, a really good foundation for a data engineer. And I think as well as an analytics engineer. I increasingly, though, think that the thing that's missing is always the kind of the understanding of the data end of things. Yeah. So that's something that's hopefully more reconciled soon. But yeah, it's a tricky one because there's so much going on with just regular software engineering right now too, right?
Yeah.
So
I think the thing I found with software engineers, and you guys can tell me if you agree with this, but I think at first they kind of struggle with the concept of thinking of data in batch. And so one of the really common mistakes for a software engineer is to just do like one piece of data at a time. Like if they're developing their own streaming system, they'll just have it pick up like one hit at a time. And even in a proper streaming system, you do want to kind of be thinking about big chunks of data and analyzing data all at once. And so there's this kind of mindset shift to thinking in terms of streams instead of individual API calls, for example. And then like you were saying, Joe, the data insight part, the insight to get into, nasty, dirty data and try to get something out of it, it takes some time to develop.
Yeah. I think it's also interesting. I think the approach of like understanding the data tools too is another area where I think software engineers sort of could use some help, right? Like with column data warehouses, we see this a lot where they treat it like a transactional database, and they like do a lot of transactions in Snowflake, for example, that might not be suitable for the type of architecture. So anyone, yeah, good good video though. So
yeah, no, thank you.
Yeah,
for bringing that up.
Yeah, of course. Got a question here. Let me just show the question real quick. I teach undergraduate business analytics students. If you could only pick 3 skills for a student to have, soft or hard skills, what would they be? And thanks, Brian, for the question. Let you guys take this one.
This is a tough one, honestly. Part of what I want to know as a follow-up is like, what is the expected skill set right now for these students? Are they mostly going to be working in Excel? Are they going to be getting into tools like Pandas? If I were to pick one hard skill, like one very specific skill, I would say at least exposure students to SQL. Like, it doesn't mean they have to be SQL experts, but just have them query some, BigQuery, some cloud data warehouse, so they know what that's like. So that if they get to a job, they can be like, oh, hey, I can use this tool that I know.
Yeah, I think SQL is kind of the one that most people will agree with. Like, it's like regardless of if you're a data scientist, data engineer, or data analyst, SQL is always the one kind of. Someone's getting a phone call. It's always the one consistent variable. Then it's like harder after that, I feel like, because the other technical things, it's like, okay, you could use Excel, you could also use like R, you could also use Jupyter Notebook with Python for more the analytics component. So that's like harder for me to say. I think like if we're gonna go with soft skills, I think one interesting skill worth kind of looking into that I've kind of learned to try to grow more into is like the whole concept of like ownership. Ownerships of like a project, a product, the whole flow of something. Especially in consulting, I think that's something that's very important. But I think it's just as important in terms of like at a company, if you can like actually like do more than just the tasks that you're provided, but like really actually own that process, make sure that people are getting connected, and like if there's a blocker, someone's moving it along. I think that's like a huge skill, and it's something that you don't pick up right away, right? Like I think that's something you have to like work in the industry and see for a while. But I think that's something that you should try focusing on at some point. After a year or two, it's like, okay, how do I actually own this whole process, this project, whatever it is? Because it's all kind of consistent. But it makes a big difference in making sure you're not just good technically and you can like fix problems that way, but you can actually bring them to fruition and to an end. Because otherwise you're kind of just stuck looping around in circles without that.
Yeah, I think ownership is such a hugely underrated I would say skill, but also just discipline in a company. Like Matt and I are kind of talking about this morning, actually, during our meeting. It's like ownership, having a directly responsible individual, for example, right? Like you own this project, you own the outcomes. Yeah, I think that's something that I wish more people would do. Dave Gonzalez, critical thinking. Yeah, totally agree with that too. But yeah, I mean, it's interesting on teams that you see that don't have a sense of ownership of things and just sort of pass the buck and pass accountability, because that ends up just becoming like an excuse generating machine at the end of the day, right? And then you kind of know where that all goes after a bit. So I think back to Brian's question, so for business analytics students, I think another skill that I could see being more kind of drilled in is just statistical thinking.
Yeah.
And thinking in terms of probabilities. I think that in and of itself is really useful for a business analyst. All too often, the business is asking for very binary answers, right? Like yes, no, right or wrong. And typically the answer isn't that clean cut. It's sometimes in a range. And I think just thinking in terms of, sort of a spectrum of outcomes is also something that I find with really good analysts, they're able to convey, ideas in terms of the most likely outcomes, right? And so that's something that I wish was more. Yeah, we're all about statistics. All models are wrong. Some are useful. Yep, totally. So that's a comment that Brian made. But then also I think, and so that's a hard skill that I would like to see more business analysts have, because I think once you have the foundation of stats and probability and just kind of basic math, like you can apply that to Excel, SQL, or Python, whatever. But if you don't have that that background, I think your analytical rigor is just not there, right? And like the thing I always look for in an analyst, and having worked as one for a long time, it's like how good are you at dissecting a problem and really assessing it? Like that sort of sleuthing ability as well is like another thing that I would say is really critical for a good analyst or a data scientist, the ability to really dig in underneath the hood, ask questions. And I think another communication communication, I think, is a soft skill, learning how to effectively communicate, effectively write, those sorts of things. So those are things I think we would probably, if I were to make like a business analyst curriculum, those would be things that I would make in a class. So I guess we do have a class, but
we do have a class. It's mostly about SQL in our case, but I suppose there will be other classes in the future. So this is something to think about. I mean, and I'm going to bring up one question that springs to mind in response to this. Maybe we can talk about this another time or write a blog post or something. But you kind of alluded to this, Joe. It's not just the analyst. It's like you almost have to retrain businesses to think in these terms, because generally when I've worked in businesses, people will come to you, executives will come to you and like, I want a SQL query that tells me this, this, and this, but it's not probabilistic at all. It's just like they're trying to tease out some kind of causality without thinking in terms of probabilities. And so it seems like being able to retrain businesses to think in these ways would be extremely valuable.
Yeah. I think that's like an interesting add-on just on the whole discussion, because again, it starts, I think, like it doesn't start with an analyst, right? Like it's going to start with that business, because you could train your students in one way or the other, but once you kind of go into the field, that's when you start like developing whatever habits you're really going to have like in your day-to-day. The stuff you learn at school is kind of just that foundation, and it's about working in companies that can actually take that foundation and then further develop on it with best practices and so on. And if you don't have that, you're likely just going to either one, develop bad practices, or two, eventually see the bad practices and then hopefully go to another company where you see some better practices and like, oh, this is how it should be done. This makes way more sense. So yeah, it's funny. It's like you can train your students as perfectly as possible, but until they're like in the industry and dealing with all the actual, being in a job problems, like, not getting your data as fast as you want or all those things, it's hard to actually see how they'll react.
That's so true. And it's interesting too, because sometimes you'll get into a company and not realize, especially with your first job, you might not realize that you're in a place that's either functional or dysfunctional, because you're just trying to learn on the job. So, how would you identify whether or not you're in a functional company?
Wow. I mean, do you have the experience or do you not? That's. And functional being like from a data side, are we talking about like maturity?
Let's simplify it. Yeah, let's talk about that. Yeah.
Yeah, I mean, I guess it's probably there's one, and even there's so many different layers, right? Because like if they're from like a data infrastructure level, are they building? Do they have some sort of process for developing pipelines, and is it being automated by one kind of central system, or is it every team kind of just managing their own thread of pipelines, and it's all kind of just patched together, right? Like that's kind of like one level as soon as just the data infrastructure itself. And then from data analytics, like it's like how are they actually going about producing like are they just mostly producing like KPIs that are what do you call it, like vanity metrics, where they're just like looking at those numbers and not really thinking about how to act on them? Are they really trying to be very diligent on what those numbers mean and how it drives decisions? Again, it's not going to ever be like 100%, right? Like there's always going to be a mix of vanity metrics and like, actual dashboards that you're using and drive things. But I want to see like some key dashboards that they're like, yeah, these are the ones that we use, right? And these are why we're using them, and the decisions that they drive. So I think there's like a certain amount of process you want to see. Like obviously you don't want like so much that stifles things, but you want enough that you clearly can see that they understand that data is not just like something you can do ad hoc 100% of the time, right? Like there's some ad hoc, but there also needs to be some like repetitive like metrics that you're looking at that are really driving those decisions that you're making.
Mm-hmm. Yeah, that's a good point. Yeah, ad hoc metrics by definition and not having solid KPIs, I suppose, would indicate that you're just sort of floating around. So there's no true north, for example. All right. Yeah, that's good insight. Anything to add to this, Matt, before we move to the next question?
Yeah, I mean, another thing I might bring up is that I think it's very, very sexy to say that you're data driven, but suppose you have accurate data, like your underlying data warehouses are producing quality reports. When you bring those to a business leader, do they actually act on the data to make a decision? That would be one thing I'd ask. Or do they just like kind of, well, this is what my gut says, so this is what we're going to do? Are they truly data driven? And then another thing I'd ask, and this is something you're pretty fond of talking about, Joe, is do you have some decisions being made automatically with data? Do you have, I mean, well, I don't know. I'll let you take this part, Joe. But basically, like you've talked about this a lot. Like if you have automated reporting and it's supposed to lead to a decision, why don't you just automate that in some cases?
Mm-hmm. Yep. Yeah, it comes back to, I think, when you're talking about event-driven architectures, especially, right? Like things that are happening too fast for people to process, mentally. And so the thing that always comes up is, oh, I want like a real-time dashboard, for example, right? I guess the question is like, what are you going to do with that information? Say that data is updated every couple milliseconds, even in a report. Like, what action are you going to take from that information? For example, could you even respond to that flood of information, or are you better off just making just making an action that just automates it? So. Yeah, but that's something I always talk about ad nauseum. So, here's a good question. Andrew Campbell asks, I have a million resources saying they're going to teach me data science, but rarely one that will teach data engineering. Do you have any recommendations for someone trying to learn data engineering?
I could put in a shameless plug and like just look up Seattle Data Guide. No, I don't have that much stuff. I think like as far as like my experience goes, there's a few obviously I think core resources like if you want to like understand the history of where things came from, go like you can find I think Kimball's data warehouse book, which will kind of understand like what we're trying to do as far as data going from point A to point B, like where's it going. That's going to kind of give you that understanding. I think if you want to learn like specific tooling, Frank Kane generally has good courses that will give you a good like high level view of things like Spark or something like that, where you're trying to understand like again specific tooling. There's also, I don't remember what the course is called on Udemy, but there's a really good Udemy course on like beginning like baseline data warehousing, because again that's just, to me that's like understanding why we're doing the ETL, which is kind of like I think what a lot of people focus on data engineering, where sometimes people look at like data warehousing as more data architecture. I think both are important for data engineers, but I think some people might be more interested in the pipeline. I don't know if that helps, and if you guys have any specific places you think about as far as learning data engineering.
Yeah, I mean, I think all of us are making content around areas of data engineering, and there's Ternary Data, or channel, and Seattle Data Guy. You're killing it with the content. Shout out to Andreas Kretz. He's doing a terrific job with coaching data engineers, and I think has some fabulous content out there. And he's doing a really good job. I think he has a data engineering cookbook as well. It sort of goes through different aspects of data engineering. But but Andrew's question is spot on, right? There's like, it's almost like a 1,000,000-to-1 ratio of like data science content to data engineering content. I think this is going to change as data engineers become, the cooler kids on the block, so to speak. And it's starting to happen, right? I mean, there's a lot of hype right now, and I think the hype's starting with data engineering. And it's only going to keep cranking up. So, I think, fast forward to a couple of years from now, you'll see a lot more content on data engineering. That certainly doesn't help you today. So, that said, there's let's see here. O'Reilly sends us a bunch of books now. This is a good book. If you haven't read this, Designing Data Intensive Applications by Martin Kleppman. Shout out to this. This is a great book. I would also say that there's, even some, I'm unearthing some interesting gems of books lately because we're in the middle of writing one on data engineering, but it won't be out till next year. So there's a shameless plug for that. But in the researching this book, I think we're coming across some interesting resources too. Like there's the Data Management Book of Knowledge. I would say that is one of the best books on data I've ever read.
Is that Dama? Is that Dama's book?
Yeah, DMA. Yeah, that's awesome. It's a bit dense, and I think it's more of a reference manual. But like that's not an obvious choice for a data engineering book. But I would say it's got a lot of valuable knowledge. So let me see any others. There was even stuff like data governance. I would say start learning that kind of stuff. Like I think Lack from Google, he just published Data Governance, a Definitive Guide, I think just in March of this year. And that one's reading pretty well so far, going through that. And then what was the other one, Matt? Data Management at Scale, I think was one that came out last year on O'Reilly. And that one's, I think, pretty good.
Also really good.
Yeah.
O'Reilly, like go through all of their like data management, data engineering type books. I think you can't go wrong by doing that.
Mm-hmm. Yeah. In fact, just get an O'Reilly subscription. That might be a good investment in your time. So
yeah, definitely. What do you guys think about tools? I mean, to me, you can't go wrong by learning. The nice thing about Redshift, for example, is that you can just go turn it on. Same thing with Google BigQuery, same thing with Snowflake. I feel like every modern data engineer should probably have some columnar analytics database skills. You might end up working in Spark, but the same principles basically apply. Like get into setting up some data and going through tutorials and running queries. And even though you're going to be an engineer, understand some things about analytics because your goal is to serve analytics and data science as a data engineer. So just go through lots of exercises with those core systems. What else? I feel like too, there's the Google Cloud Platform Professional Data Engineer exam. It's really hard. But maybe just going through the syllabus and looking at some of the tools, and not the Google specific ones, like you don't necessarily need to get certified on Google Cloud, but just understanding the context of each type of tool and each type of database would really go a long way for you.
Yeah, I think that's one thing that's like really nice about like being a data engineer today. It's like it is that easy to like learn about the tools where it's like oftentimes you can get like $300 of credits for like AWS or BigQuery, and then just set things up and start playing with it. Even if you're not planning to take the exam for any of your AWS or BigQuery, it's like I think it's GCP, basically data engineering. There's a lot you can learn just by like turning it on and being like, oh, how do I connect to this? How do I connect to it in command line? How do I connect to it? Even I think all that can take a decent amount of time. It's kind of interesting to learn. It's interesting to learn even things that seem like maybe more system admin, like policies and permissions. Like that's such an oddly important thing to know. It's because it could be so frustrating in the future where you're like, especially if you're dealing with someone else who's managing it and you're like, okay, I need you to give me this access because I can't do these things. So even being able to know what to ask for in the future. So yeah, I think that's
Now what are you guys' thoughts though, right? So occasionally you'll see people saying, oh, well, data engineering, to be a data engineer, you got to learn Hadoop. You got to learn, Yarn. You got to learn Spark. All these things. What are your thoughts on this?
I assume it depends on the company. Like, I'm sure there are companies that like maybe have those technologies in play, but I mean, I don't know. I've gotten away with mostly SQL, Python with most of my work. Like, I've not had to touch Hadoop at like that granular of a level. Like I spent so much time trying to learn and like learning everything about it, and then never had to use it, which is like very it's a little bit like what's the term I'm looking for, demotivating in terms of like learning more about it. But yeah, it's like so many, like I think people realize it's really hard to do that kind of work, and it just makes sense to abstract it away. So oftentimes you might still have like some system admins or some software engineers managing it, but on your level, you might not be touching that very like low level of Hadoop or something.
Right. And don't you work at one of the FANG companies, by the way?
Yeah, I mean, like that can
So,
just, like, if you want to add to that point, sure, yeah, exactly. So it's like, it's one of those things where it's like, I do think that that's a benefit. Like, I think some other companies, maybe they're still kind of trying to maybe utilize, Hadoop at that lower level, and so they're running into a lot of problems where they're having to, write their own MapReduce jobs, where it's like, yeah, but you could stick Hive or Presto on top of it and really take away so much pain. And then if Presto is not good enough because of security, I think there's tools like Starburst Data that are coming out to add like all the kind of enterprise level stuff to it. So it's just one of those things where it's like, how much do you want to spend on just buying a product that will essentially do the work for you, or do you want to spend 3 times the amount on the number of engineers it's going to take to basically do that kind of work? So.
Yeah, and I tend to agree with that assessment. So especially the Hadoop tools, I mean, this is what I would recommend. You're not going to hurt yourself just experimenting with Hadoop in the cloud. And Hadoop in the cloud is a very different experience. You're not managing software updates. You're not managing data distribution generally. It's just go into, if it's on Google Cloud, go hit data proc. If it's on AWS, then look at EMR. I think if you're in Azure, it's still called HDN sites. So you can spin up a cluster, and it will take like 5 to 10 minutes to go through the tutorial. Just see what it's like, run some basic jobs, that kind of thing. I think at this point, there's almost like a cultural aspect to becoming a data engineer. In other words, if I were hiring someone, I'd want to know that they have good data insights, and I want to know that they kind of understand what these different tools are for. Where might I use Spark? Where might I use Presto? Have a sense of the ecosystem. And if I know that they have strong, they're self-motivated, they're good learners, they have general data insights, then I can teach them Spark. They can learn Spark SQL, they can learn PySpark. But yeah, I don't generally treat Spark in particular or Hadoop as a baseline data engineering skill. I think I would like my engineers to understand that Spark is really good, not so much as a big data tool anymore, because Joe and I are fond of talking about this. We're kind of in this post-big data era because you can do big data with SQL very easily. But I want them to understand that, programmable data frameworks like Spark have a place. If you really need data frames or some programmability that you're not going to get from SQL, then you want to look at one of those frameworks. But I also want to know that they understand what can be done with SQL in something like a Redshift, for example.
Yeah, I think it's interesting, the layers abstraction. We've been writing about this too. I think it's back a few years ago, there was an article about type A and type B data scientists. Type A is more of an analyst. I think type B is more of a builder. The same thing is actually occurring in data engineering right now, where I think your type B, the builder types, are typically going to be writing customized workflows or building something that's very specific to their organization that a canned tool may not be used. But for the most part, a type A data engineer is going to be focused on just stitching mostly managed service prepackaged stuff together, right? So, and I think increasingly that's type A tends to be where people are going, just because everything's being abstracted. And strangely enough, it's these people who have built your Hives and your Prestos, they all started managed services companies. So like a couple of them from Facebook, for example, Martin, the guy who wrote Presto, now he's at Starburst and he works on that. He still works on Presto, but it's so it's interesting. And I think and I'd say the other thing is just stay current with tools. Like there's DBT, like that's all the rage today, and I think for the next couple of years, who knows after that? I'm sure there's going to be something else, but workflows are getting easier. But I think it also means like you're going to have to take a step back and really understand, I think, what you guys are saying, just a broader ecosystem too, and just understand like how do things work along the data engineering lifecycle. How do I modularize my services in such a way that I can swap things out and not get stuck with a crappy monolith? Because everything's moving at light speed right now. Everything changes. The stacks that you see today are not the stacks you're going to see 2 years from now. There's going to be a lot of changes in between now and then.
That's definitely true. And then I would say, it's funny, like moving into the cloud, used to be writing these raw Hadoop MapReduce jobs were inside of this Hadoop walled garden. And a lot of what data engineers do now is happening through APIs. Like they're issuing SQL queries, they're issuing commands, they're spinning up infrastructure and spinning it down. And in terms of managing the data lifecycle, you're either orchestrating, so you're using something like Airflow or Prefect to manage these services and get things done, or you're thinking about streams. And so you're using Kafka and then somehow processing the stream to get data where it needs to go. And so high level, you want to understand those big paradigms of orchestration versus streaming.
Here's a related question. There's actually a couple on tasks that we've seen. So, but I don't know. You want to take this one, Ben? But so I think.
Right. How important is it to know about or have experience with new tools like Dask? Wow, that's so, like, I think we kind of almost lightly covered why it's like, it's both important and not important to know. It's like, it's one of those things where it's like, tomorrow Dask could be like the pig or whatever old technology of yesteryear. I mean, people are talking about data lakes as if they're going the way of whatever. I actually don't have a good example there, but it's just one of those things where it's like there's no way you could keep up with every new tool. It's like if you could, it is its own job, right, to some extent, because you're talking about Dask, which is more on the programming side, but then you also have things like Fivetran and like all of these other tools that require like learning in its own right. Like it's not like you can just click and jump into these tools. There's a lot of like best practices there as well. So I think I talked about this last time. It's good to know that they exist. It's good to know what they are for. Maybe do a few tutorials, play around with it, get familiar with it. But I think like depth depends on where you work, right? Like you'll learn depth wherever your job is asking you to learn depth. If you're interested in Dask because you want to learn about it, then do it. But other than that, like personally, you'll get plenty of depth at a company when you get time to play with that tool.
Yeah. Yeah, I mean, there's a follow-up question here with Tiago asks, your thoughts on Dask and the data pipeline. I think I think to your point, it depends on if you're going to need it or not. So I mean, there are some advantages to using. I think if you wanted to sort of parallelize out, your Python workflows, but there's a lot of ways to do this right now. So, but I mean, I see people using Dask successfully. So, I mean, I think it's a cool tool for what it does. But that said, it seems like there's almost too many good tools these days.
I think that's true. Yeah, it's very tricky, right? Because the problem with Dask, from my perspective, is it's like, where do I draw the line? My team's really good at Python, between continuing to use Python and scale it out and saying, maybe it's time to go to PySpark instead. Like I can still use my Python skills, but Spark is just going to be more performant than raw Python in most cases. Yeah, and I guess a lot of it would be like, where are you trying to get a job? If you know that a particular team is doing a lot of Dask and you really want that job, then maybe learn Dask extremely well.
Mm-hmm. Yeah, exactly. But if they're using Spark, right? I mean, exactly. You can scale out Dask on clusters too, and so forth. But it's like, I think the answer to your question is it depends a lot on what team you're on, honestly. Yeah. So, I mean, if everyone's using, framework X and you somehow want to use framework Y, I mean, that normally isn't going to sit well with your team.
Yeah.
So, or it might, depending on like how rebellious everybody is. I don't know. So, it's like a hippie drum circle and everyone just does their own thing. So, but yeah, it's interesting.
It's a big question in data engineering, though. There are so many tools, and it's hard to give advice around this, except to say, I want to see that you have data insights, and I want to see that you have technical skills. And beyond that, I probably have to train you to whatever stack I'm using. It's just a reality, because there are just too many tools. It's very hard to find someone who knows exactly the tool that I'm already using.
Mm-hmm. This is an interesting question. You want to take this one, Matt?
Interesting. Yeah, I don't know the answer to this. This is very interesting. I can tell you anecdotally what I've kind of seen with data engineering, and you guys can tell me if I'm just full of BS or something.
Well, you are. I mean, let's just get that out of the way. So
just keep talking. Eventually, you're going to say something wrong. So, I mean, anecdotally, it's funny, but I find that people who like pure math and writing proofs. I know several people with PhDs on the more pure side of math who've become really competent data engineers. And I think it's something about the problem solving skill set that comes from that. Lots of other people have done it too, but there just seems to be some kind of alignment that if you like drilling down into logical details, then data engineering might be very interesting to you. And people who have worked more on the statistical side of things, who've done I don't know, who've worked on biostatistics or applied math, tend to make good data scientists. But obviously that's anecdotal, and lots of people transition from one to the other and are very, very successful.
Yeah, but I guess is that what he's asking?
He's asking to try to get a data set and then find features that would predict. And so and just intuitively, I feel like some kind of feature around type of education might be very interesting and where people were successful. But I don't know where you would get that data set.
Yeah, but and I think that there's also just so many other things you probably want to look into. It's not just education, but it's that's such an I don't know. It's a very questionable question.
It's an interesting one, right? Because you're trying to predict outcomes at an early age, but it's interesting because you tell me successful people, right, who give good economy to the country or something like that. Who are the most financially successful people right now?
Yeah.
Right.
We're talking about Mark Zuckerberg.
Mark Zuckerberg, right? by most accounts, dropping out of college probably wouldn't be a good indicator, right? So your college data set goes out the window. Let me see, Bill Gates, college dropout. Elon Musk, I don't think he was that spectacular at school. Warren Buffett, he was okay at school. Let me give you another counterexample. This is a graduation from Mike Wimmer, who's 12 years old and just graduated high school and college and runs a robotics company, and he's 12. So, and if I were to look at his trajectory, I'm like, this kid's going to be if he keeps at his current pace, he's going to be the next Jeff Bezos or Elon Musk. Not even a question, but a lot can happen between now and then too, so maybe he just won't, but then again, it's one of the wealthier people I know. I don't think he finished high school at all. And he just.
Okay.
No, go on.
The other problem here, it's you're obviously talking about outliers in this whole thing, right? As the aggregate and the average, most people that are if you were to remove them, which obviously is not great for math, but you would see that most people probably did graduate college that are quote unquote successful, or if you were defining success by money and being good for money, for the economy, right? That tends, I think that statistic's still true, right? Where if you graduate college, you make whatever, $1 million more or something in a lifetime. So it's just one of those things where it's are we looking for the ones that really drive the economy, those 10 outliers, or are we looking for the average college graduate who's arguably going to do well? So it's just so broad.
Yeah, and I think it's just it's one of those things where I think people try and if you're using the average to predict success, you're going to get average success, whatever that's defined as, right? And so by definition, it's. Yeah, I mean, it's an interesting question. I don't know that it's a solvable problem.
Yeah, I mean, I'm sure at some point it will be, with the amount of data you could, in theory, predict it. But maybe we have it now. I assume we don't, or if we do, it's I'm not sure I can think of any good data sets because it's so personal too. That's such personal information that you have to get grades and incomes of families and all stuff that. I don't see where you're getting that information from.
And do you have the opportunity to succeed, or are you in in some countries in a caste system where you're not going to succeed no matter how hard you try, right? Or even in America, not to get too social political here, but it's if you're in certain areas in this country, your chance of success is pretty low. Just depending on the ovarian lottery, as Warren Buffett calls it. If you happen to be born into great circumstances, and then you're going to probably have better outcomes versus somebody who just isn't that fortunate. So there's a lot of factors that go into this. I would say I wouldn't be building this. And plus I'm scared of the outcomes of it too, just because you start gamifying society and outcomes. I think that's, America, especially, like this country is special in a lot of ways because we allow people to take risks and have serendipitous outcomes, right? Like whatever you want to do, basically within reason. Obviously, you can go start cults, you can go, start pyramid schemes or whatever, or you can go start a company, or all the above. And it's just, and there's a lot of ways to be successful, or you could just do nothing, right? That's your choice. So, and maybe that person feels they're successful. So I don't know. Now we're getting kind of philosophical here, but anyway, interesting question. Here's a giant question. Let's read it. For someone not looking to work at a company and therefore having the luxury to choose which technologies they would use for data engineering tasks, what would you recommend? I currently build our out data engineering pipelines and automation using R and ECS and EventBridge and AWS. I haven't really come across any issues. Is there any reason I would want to switch to more traditional data engineering tools like Airflow or Spark?
So I'll say here, it sounds like based on the tool set you're using, that you're focused, you're probably doing consulting and you're focused on a very particular data engineering niche, which is great. I think consultants do well to find things they're very good at and just say, this is the tool stack that I'm going to build and this is what I'm going to focus on. And you might be a fit or you might not be a fit. I think you're going to probably switch to Spark if you have bigger type analytics batch problems or something like this to deal with, as opposed to maybe some event-based data that's not massive. Like R has gotten more scalable, but it's challenging to scale versus Spark, which is just built for scaling from the ground up. But yeah, if this is working for you, I'd probably stick with it, but just keep an eye out on other things that are out there, just depending on the use case. I don't know. What do you guys think?
Yeah, no, I think that's kind of similar to my answer. It's one of those things where it's like, is it worth for you to switch, right? Like, it's going to take time. If you've only got a few pipelines you're managing and they're fine, then it's fine. Once you start managing like 1,000 pipelines or 10,000 pipelines, like some large companies do, it's like, yeah, you need to start thinking about something that's more infrastructure focused. It's not just like, kind of piecemeal together. It's something that's actually managed and monitored, like Airflow or Luigi or something like that, where you actually can see all the processes, you can deal with failures, you can deal with monitoring. So yeah, it really, it's always going to depend on that use case. Otherwise, switching, it's like, if you only have one data pipeline and it's all patched together, Python using a cron job, is it the end of the world? Probably not. Like, if that's the only one, fine. If you're, again, trying to manage 1,000 and all 1,000 pipelines are managed that way, that sounds terrible. I don't want to have your job. So yeah.
That's pretty funny. Yeah, I would, if it's just you don't have if you don't have a need to do anything, I would say just use. I mean, I used to work at this place where the developer wanted to use F# for everything. That was fascinating because there was like this. Speaking of cults, there was like a cult of like functional programmers, and so they were like, everything must be functional. We can't have any object-oriented programming here, and so because they had the blast radius for what they're building is pretty minimal, right? It's just the developers that were building it. I guess it didn't matter, but I would say the moment if your situation is such that I think you should point out, Ben, you got 1,000 pipelines, or maybe you just have 1,000 people working on this thing, then it's not just about you anymore, right? And so that's how I'd kind of frame it. But yeah, I mean, if R and ECS and EventBridge is working, like, who cares? Like, get really obscure. Use like Fortran or something. I don't know. Like, but yeah, I mean, there's no risk. But I think to answer your second question, though, right? Is there any reason I'd want to switch to more traditional data engineering tools like Airflow or Spark? My thoughts on this, it's like, maybe if you're curious. So, you want to try things out, go for it. Never stop a person from trying to learn new things. So, but that's really up to you.
Yeah, I mean, in consulting, you kind of get to create your own job. Like you build a skill set and then you go sell it to a bunch of people. So if you want to be doing Airflow, then maybe go learn it and then sell that skill to other people, or Spark. Same thing. The nice thing now is that it's so easy to spin up these systems, when a few years back it was a huge headache with lots of server installation and such. And so, yeah, decide what you want to be doing as a consultant and then steer your career in that direction.
Cool. I'm trying to go through the questions here. Yeah, if anyone has questions, obviously type them in. We'll try and get them answered here. So, I get, kind of back to the question of learning data engineering, though. Like, if you're starting out from scratch, how do you think you'd become a data engineer in 2021?
How have we done it? I mean, I think we've all done it through jobs. Is that basically correct? I think that was your experience, Ben. Like you just had to do it for the job. I ended up doing it for my job. Joe, you kind of decided that this was where the high value work was, as you were working on problems from more of the data science side initially. It's tough, right? If you're not in a job where you're going to pick up these skills, I think mentorship is really critical in that case. You want to find someone who's guiding your training, because you're going to have to be an autodidact. And so at least if you have someone telling you what you should study, you're going to be much more successful.
Yeah, what are your thoughts, Ben?
Oh, sorry, the mute button. Yeah, no, I mean, I kind of agree there, where it's like, again, data engineering, there's no undergraduate degree for data engineering right now. Funny thing is, like, there is one now for, like, when I was like looking for a person to intern, like I was getting people who had like undergrad degrees in data science, which to me was just like, okay, when I was in school, which was not that long ago, right? Like, I mean, in the grand scheme of things, right, it wasn't that long ago, and like some of these schools have like developed an undergrad degree in data science, and that just doesn't exist in the data engineering field, whatsoever. There are some, like, I think some maybe certificates and some maybe master's degrees in like IT that, or like IS, like information systems, or MIS, that you might learn the skills, but like overall, yeah, it's like at the end of the day, data engineering is like mostly from the job. I'm trying to think, like it's often really hard. It's like even harder to replicate like working in like a production environment for data engineering, I feel like, than it is for like software, because like you don't have the data. Right, and if you could, it would be so expensive for you to manage. Yeah. Like, okay, I have it all on this, whatever Redshift instance, and I'm spending $500 a month or more just to try to like build these pipelines. It's not really worth it for you. Yeah, I mean, like, I think there are plenty of startups that need data engineers. So if you're like a software engineer or an information systems student out there that wants to like learn how to do it, especially from like more likely the ground up, that would be a great place to start for most people. I think that's where I learned a lot of my skills, was like working with startup, working with really smart like people that were kind of the mentor, that mentor figure that could kind of help me like learn the best practices along the way. Right? Like, you don't want to be the young data engineer out of college and there's no one there to guide you. But yeah, if you can get one like in a startup where there's someone who's maybe more senior, I think that's probably a great way to go. Because again, you're gonna have to do so much of the work. Oh, how do I manage like an easy like all these various like cloud components and things like that. So yeah.
Yeah, it will be cool to see, maybe a university degree on data engineering at some point. I'm curious what that curriculum would look like. I don't know. If you, I guess, to close it out, if you were to design a data engineering curriculum for an undergraduate degree, what would that look like?
Personally, I almost feel like it's like maybe like you like add it as a top layer onto like either a software, or again, like information systems degree, where it's like it's just a minor, like more like, or you specialize in that area. Like, I don't necessarily think data engineering by itself, I don't know, does it have a full degree worth of stuff? I guess maybe, but I feel like more than likely you're gonna like stick it on top of something, or like specialize in it, right? Like with a business degree, you're a business, but you're like a marketing major or whatever. So maybe like they make more of like a generalized data degree, and then you can like maybe go more the data engineering route or data science route or something like that.
Yeah, would you throw it on top of like computer science,
Yeah.
or do you think you would or would there be like a data? Because you bring up an interesting point, like a data degree. That's actually a pretty fascinating idea. Um, hmm,
It's arguably more practical, right? Like when you think about it from the perspective of like the business, it's like what are some of the big jobs today? Data analyst, data scientist, data engineer. But the degrees are like economists that kind of go into that, or again information systems, finance majors, math majors, but they all kind of end up funneling into very similar positions. I'd say.
yeah, yeah, and hopefully data literacy is also taught. I think more in these programs. The non techie, non data ones. That is. Actually, Avery got a good point. What's up, Avery? Avery's awesome guy. Just moved to Utah. He's got some cool Python courses as well, so go check out his stuff. But yeah, he has a good point. I think degrees will decay pretty hard within tech in the next 10 years. It seems like there's an expiration date on a lot of the content of degrees, especially when you're talking technical degrees. I think computer science does an okay job at this, where they focus on maybe the underlying stuff, like compilers, for example, right? Algorithms, kind of more of the internals. But it's also at the sake, I think, of having an applied understanding of how maybe data systems would work. I still think you're going to have to do a lot of work outside of your courses to, I think, be effective maybe as a data engineer, for example. I mean, I see this with comp sci graduates who end up becoming like software developers, for example, like mobile or web. Like a lot of the stuff they learn is practical from a CS perspective, maybe underlying, having a base foundation of computing best practices, but then trying to apply that to building an app. It's still like having like a second degree almost by the time you're done.
Yeah, and so, I think that's why you see a lot of you'll see a lot of like CS majors still go to like a boot camp because they're like, oh well, I didn't really learn front end or like modern front end or mobile development or like all these other aspects of it, where it's like the CS degree like gives you the baseline, but then you still need to specialize. And I think it's the same thing with like data and data engineering and things like that. It's like, yeah, you need all the basic principles from like software, or at least some of them, and then from there you just need to choose a specialization.
Yeah. Who's it? Sorry. That's from Alex Wolford. What's up, Alex? Also known as LinkedIn user. Good alias.
That's just it. It will be out of date. I mean, especially even if I developed an up-to-date, say, trade school type curriculum that was 4 years right now. It's like, okay, you're going to get a bunch of cloud certifications. You're going to learn Spark. You're going to learn SQL, Airflow. By the time someone graduated, like this stuff would probably be kind of entering into life or like maintenance phase. There'll be new cool stuff coming out. So yeah, you need to pick up general skills that can transfer, but it's a tricky problem. I think specialization with like a general theoretical degree makes a little more sense, like you guys are saying.
I mean, we're running into this even writing our book, right? Like we're writing a book called The Foundations of Data Engineering. You want to talk about like a ballsy topic to try and tackle like that? It's tricky. And even our editor, she was like, "You guys are nuts," because there's a lot to tackle here. But so we're trying to focus on the underlying things, right? Like not being technology specific too much, precisely because there are certain trends that I don't think disappear. Things like data ingestion best practices, ways of storing data, ways of processing it, and so forth. I guess those are the things that maybe are immutable, but I don't know that it's debatable whether or not you can make an entire 4-year degree out of that kind of thing. Like what you can do spending like the first year like going over like ingesting data. I mean, you could. It seems like that'd be a gnarly course. You'd be bored to tears after like the first month, but.
And I think like that's why I'm always like you brought earlier up the fact that data engineering maybe we're becoming cool, and I'm just like, it's not that I don't want to believe you. It's like I remember my like database course in college, and I feel like I've talked to everyone I've ever talked to at like their database course in college. It's so boring. I love working on databases, but for some reason like the course is always just so dry. It's like when you're talking about like normalization and like structure, it's like there's very little things that are exciting about that. Like you can try, I mean, and if someone can do it successfully, you know, that person will probably make a ton of money off like YouTube AdSense or something off a course. But it's definitely a hard topic to make interesting. Because again, like, oh, why are we doing this normal form? Like just talking through like deduplicating like structure like that. It's like it's hard to pay attention to. You know?
Yeah. Actually, got a related question here. What are those general skills evergreen a data engineer should focus on right now? I think we kind of hit on this a bit, but understanding the data lifecycle, I suppose, is key, and how technologies sort of fit into that might be one way to go. I don't know. We can sort of in a roundabout way kind of answer this for the next couple minutes. So.
Yeah, and getting the access to data, if you have a way of actually getting interesting data to work with. I mean, various vendors do provide data samples, I suppose. Like Google has a bunch of different data samples you can look at. General data insights, like I take a raw data set, how do I actually turn that into some kind of information about behavior or business processes or something like this, using SQL as a starting language. And then just, you know, getting exposure to various tools, because again, the problem is that you go deep on one tool and it almost narrows you too much for the job market until you actually get a job.
Yeah, and it's also kind of hard because it's like I think some people focus heavily on like key concepts rather than like maybe what the key concept's trying to do. Like, oh, you know, ELTs are the thing. Okay, but why are we using ELTs like versus ETL? Like, why are people kind of switching to that concept in like versus ETLs? Like, what's the business need? I think it's more important to kind of understand just data pipelines in general. Okay, ETL, ELT, how do we get data from one point to another? If we do an ELT, like, okay, what does that mean down the line? How do we have to manage that data down the line? Because it does change a lot of those processes. So it's like you said earlier, you know, you have to think about the whole data lifecycle kind of and the skills that are involved in there and the high level skills that are involved in there. So it's like I said, data ingestion, data storage, and then like how the people access data, or, you know, I think are kind of those key areas that you need to end up looking at. Obviously it changes, but like understanding the concepts under there, it's like data warehouse, data lake, modern data warehousing, you know, how's that different than like, you know, maybe old school, like cloud data warehouses are, you know, designed differently. And oftentimes that means you are forced to, maybe you can't use slowly changing dimensions or something as easily or something like that, or you have to change how you do it because, you know, it's more of just a write heavy and not a lot of updates. And so there's a lot of little things along the way. So I think it's like building that foundation in like, okay, again, those key concepts, data warehousing, data warehousing, ETLs, ELTs, and not focusing, I guess, too much on tools right away.
Right. Yeah, and I think maybe, you know, to add to that, maybe if you're to look at some specific skills, technical skills, I would say that the stuff that is sort of the primary technologies, for example, or languages you're going to come across, like Python, probably going to come across that, so learn that. SQL, probably learn SQL, so come across that. Shell scripting, learning, getting comfortable in the command line, I think that's a good investment of your time. Maybe if you have to learn a JVM-based language like Java or Scala, if you're dealing in one of the big frameworks, I don't know that it would hurt you. But I'd say that those might be some other specific technical skills to adopt just because they come across everywhere, right? Even in the days of managed services where everything's abstracted, I mean, you're still probably going to need to write some code. If you aren't, then, you know, you're cool and stuff. But yeah, I would say those might be some other ones. Especially, I think the command line is like highly underrated. Like that's like one area where I think you could go deep in that and like just like 10x your performance as just a human being or something. So
and what's great about that these days is you do not need to spend an entire weekend, you know, setting up Linux on your computer. Just spin up an EC2 instance and have at it. Like no need to just, you don't even need to mess with all that stuff. So.
Yeah. I mean, even easier, I don't know if you mess with GCP much, but their Cloud Shell, it is a Linux environment. So you like open an account and it's just right there. Linux, just click the button and you have Linux up and running. So yeah. But yeah, even a small EC2 instance, if you do a small version of it, it's going to cost you a couple bucks a month to run.
Yeah. Well, other skills too, like just understand, like, we're talking to somebody about this today, like understand networking, like just basic stuff like that too, stuff that you're going to come across in your job. Like as a data engineer, you're going to need to connect systems together at some point, right? I think understanding how networks work, it certainly doesn't hurt you. I would say it hurts you if you don't know how these things connect. So,
yeah.
And then general cloud skills. That's part of the reason that data engineers need to know networking, because in a cloud environment, they definitely don't necessarily have a dedicated team of network engineers. A lot of people have to wear a lot of different hats. But yeah, learning about the fundamentals of AWS and GCP and Azure, that's not going to hurt your career. It could take your career in a different direction, but it's a really solid foundation for modern data engineering as well.
Cool.
All right.
It's 2:00. So.
All right.
All right, everyone. Good talking.
Yeah. We'll do this next time, maybe in a couple weeks or something like that. So, to the audience, thanks to everyone who showed up. It looks like we actually have more people now than ever on LinkedIn Live.
Oh, cool. How many people made it this time?
Oh, thousands. It's a very popular show. So
we're filling a stadium.
Yeah.
Thousands. We need to start selling ad space.
Yeah. Buy our merch. Just kidding.
Get out the t-shirt gun, Joe. Like, let's.
Yeah, exactly. Yeah. Well, awesome. Anyway, thanks, Ben and Matt. It's always fun chatting with you guys, and we'll do it again soon. So
yeah, thank you guys.
Awesome. All right, thanks.
Take care. Have a great weekend.
Thanks.
Bye.